My name is Anton Kolonin, and I'm going to present our work that we have done for making adaptive predictive portfolio management agent operable with cryptocurrencies on crypto finance markets. The work has been done on SingularityDAO and SingularityNET, and the work is extending our earlier work on adaptive multi-strategy agent. We just improve the quality of our work with capacity for price prediction, and we upscale our technology to operate across multiple assets for portfolio management purposes. The basic idea of adaptive multi-strategy agent is this. We have the controller agent operating two swarms of agents. The swarm on the left at the bottom is the swarm of the agents executing whatever imaginable possible strategies that we can set up, and these multiple strategies are executed against virtual environment performed by our simulation and backtesting framework, being fed by the market data streamed from the real exchange. At the same time, the adaptive multi-strategy agent controller is picking the agents from the left swarm that are presenting the best strategies. The best strategies are the strategies that maximize the profits and minimize the losses. So the best strategies picked from the left swarm is being used to populate smaller swarm of agents on the right at the bottom, and these single strategy agents are executing the winning strategies, the strategies picked from the left. And these winning strategies are executed against the real exchange in real time. And so only the best strategies are permitted to be executed on the real exchange, and the profits are collected accordingly to these strategies. The operational space for such market making agent, for any of agent playing particular strategy, is presented on this slide. The agent is collecting sensory input from the market data and from media data. The market data is about trades, limit order book snapshots with multiple levels, aggregated pricing and volume and trade count data, and also that's social media posts from Reddit and Twitter. All this data is being collected and preprocessed with features built. So market features are all possible trend indicators, volatility, and imbalance metrics computed based on market data, and social media data are the metrics for sentiment and metrics for cognitive distortions being evaluated accordingly to technology that is being employed by cognitive therapies that are working within cognitive behavioral therapy paradigm. Then, based on the observed signals, agent is making decisions about which parameters of the strategies that are going to execute have to be set. So one of the key parameters is a spread, the difference between the bid and ask prices. Another hyperparameter is a cancellation policy. So the cancellation policy is a threshold which indicates how much should be the price change so the current orders are closed and the new orders are created. Then there is a refresh rate, how often we reevaluate our orders in respect to closing them and opening them. And all these parameters are fed into particular strategies. So the strategy set up with these parameters is being implemented by trading bots, and the trading bots are performing particular asks, making bid and ask orders, or canceling these orders, or making straight buy and sell market orders. These actions are executed based on the parameters accordingly to the trading bot algorithms. Now we are extending this work to work across multiple assets. So we add one more hyperparameter. That's one more, an additional hyperparameter is the market. Agent is free to select any of the markets that he has in his investment basket. For example, here you see example where we have the portfolio or investment basket built of 4 coins like Ethereum, Bitcoin, AF, and UNI. And on one hand, you can split this portfolio in terms of amount of particular asset on this portfolio. That's on the leftmost column. but also you can split your portfolio in respect to different strategies being used to execute the assets on particular segment of the basket. Like some of the funds may be locked in hodling, that's second column, but some fractions of the portfolio can be used to perform market making with particular parameters. Like at the bottom you see that every vertical column for market making activity is associated with particular strategy with different sizes of thread and thread cancellation thresholds. So here you can see the example of simulation and backtesting on this multi-asset, multi-strategy, adaptive market making. On the left, you can see, for example, that with 2 weeks or 1 week per strategy valuation threshold, you can select the best profits, and the best profits you can get with different configurations of the agent are exceeding 15%. Moreover, we can explore how particular strategies and parameters of these strategies are associated with particular market conditions. For example, on this cell you can see that the most profitable market conditions are those where the trade volume is exceeding 0.90, so that's normalized market volume. So that confirms quite obvious observation that market making is profitable with greater volumes being traded on the market. But that's not all, because besides quite obvious conclusion that the more money is on the market, the greater the profitability of market making, you can also find that the algorithm is able to find the sweet spots for market making under those conditions. You can see that in terms of observing the maximized profits, which are indicated by green cells, and avoid cells with maximized losses. These are red and orange cells. So here you clearly see that the most optimal spread interval is under around 0.5 and 0.01% and under 0.1%. So these are sweet spots for the spread threshold. And then the other thing that we can do is use social media analysis for price prediction. So here you can see about 16 cognitive distortions metrics indicated on the left, and top of these metrics, 4 of them on the upper side of the slide, are represented by cells where the dark green cell is corresponding to the maximized expression of the particular cognitive distortion metrics. And you can see that some of the metrics are clearly associated with market crash situations, like some of them here is corresponding to early crash indicators, and the next one is corresponding to late crash indicators. So we are using these cognitive distortions as extra features for price prediction algorithm. Overall, we are using 20 social media metrics. 4 of them are for sentiment analysis and 16 of them are for cognitive distortions, and we compute these 20 metrics for every of 200 social media channels across Twitter and Reddit. And here are results of our ability to make the price predictions. On the upper slide you see how the price prediction based on the social media data can be based on daily basis. The blue bar corresponds to ground truth price difference, actually not price difference but actual price, and the orange plot corresponds to the predicted price. And what you can see on the upper plot, that prediction is not quite accurate because typically we just have some delay, so we predict the price after the price is changing. But if we move to hourly based predictions on the plot below, you can see that in case of the most significant price changes, the orange plot changes up or down at the same time when the blue plot is changing. So we typically either anticipate the price change, or we can tell, or we are at least not making the wrong predictions. So we can make the prediction either 1 point before the price is changing or 2 points before when the price is changing, in the case of dramatical price changes. And here are the final confirmation of efficiency of our approach for price prediction. We are here we are running two different experiments. On the left you can see the results of predictive market making, adaptive multi-strategy agent performance in a case when every of the strategies and every set of hyperparameters that we are using for every agent is also backed up with the price predictions. So all agents involved in the experiment on the left are able to do the price prediction based on the social media data. In this case, you can see that in half of the strategies surrounded with green circles, agents are able to get return of investment above 10% over 3 months, and in the best case the return of investment can exceed 25%. On the other hand, on the right, here is what is happening if all agents with the same set of strategies, with the same hyperparameters for strategy selection, are not able to make the price prediction. So you can see that only the one strategy is capable to do positive return of investment with very low rate at 1%, and most of the other strategies are just leading to losses. And thank you for attention. You are welcome to read our papers presented on the conference AGI 2023, and stay in touch, and thank you for attention.